In today's video, we're going to be looking at word problems involving exponential functions, more specifically, problems that include exponential growth or exponential decay. So we're going to be given a word problem, a scenario, and we have a formula to kind of work through and plug in the different numbers into the formula and be able to predict what kind of exponential growth or decay occurs. Okay, so in this first problem, well, first let me show you the exponential growth or decay formula or exponential formula. So this first value right here, whatever goes out in front, is going to be the starting value. So in the word problem, if it has a starting value, it goes right here into your formula. The base here is that's going to depend on whether it's growing or decaying. And we're going to show those scenarios. And then the x as the exponent is going to be the time interval. So you're going to plug in whatever time intervals go in for x. Okay, so just keep that in the back of your mind when we're reading through these problems. So it says in the first problem, a town has a population of 12,000 and grows 5% every year. What will be the population after 12 years to the nearest whole number? Now, a couple things. Make sure your 5%, you got to convert that into a decimal, which is 0.05, right? That's 5%. And that is growing, okay? So I'm going to show you how to plug these numbers in for your growth. So again, back to this. This one's going to be growing. Your starting value, what's your starting value? If we look back in the problem, our starting value is 12,000. So I'm going to write y equals, oh, I didn't want to write with this. Erase. Bam. Okay, I'm going to write with this one. Y equals 12,000. That's how you're starting off. Okay, now we know it's growing, right? What's it growing by? 5%. So whenever it's growing 5%, you have to add that to 100%, right? So 100% is 1. So you're going to plug in 1 plus 0.05. All right, since it's growing. If it was decaying, you would do 1 minus 0.05. All right. And then the time interval is 12 years. So you're going to plug that in for the time interval and for the exponent. So there's our formula. And what's nice is we could just plug this all into our calculator. 12,000, 1, 2, 3, parentheses 1 plus 0.05. We're adding that to 100%. Exponent button to the, was it 12? Yep, 12. 12. Now you get this long number, but we want to round it to the nearest whole number. So it is this number right here. I wonder if it's going to let us copy and paste it. That would be really nice. Yep, it does. Let's see. Submit. Yes, I don't need that thing anymore. Okay. Let's look at another problem. Let's try to do another growth one. That decays. Let's do a growth one. Depreciates. Man, these are all depreciating. Let's do a growth one. All right, here we go. 4.5%. All right, so this one, again, we start off with 13,000. So the only difference is I'm going to change this to a 13,000, and it is growing 4.5%. How do I write 4.5% as a decimal? Again, I move the decimal over 2 spots, so it's 0.045. So in my calculator, I'm going to put in 0.045, right? That's growing. And then 13 years. So instead of 12, I'm going to put in 13. Bam. And it is this, and the 0.5 rounds it up. So it's 23,039. 23,039. Bam. Okay, now let's look at a couple of depreciation ones. Of course, it's going to give me all a bunch of growth ones now. Watch. Okay, here we go. This one starts off at 20,000. So again, for this one, 20,000. Yep. And it depreciates at 12.5%. And so instead of adding it, we're going to subtract 12.5%. So how do you write? You move the decimal over 2 spots, 1, 2, right? 0.125. That's how it depreciates. So in our calculator, 0.125, right? That's how much it's depreciating, 0.125. And after 11 years, so this one, instead of 13, it's going to go to 11. Okay. So again, we're still using this formula, right? Your start, your decay. The only difference is with this, right? We got 20,000. Need one more. Okay. And it's 1 minus 0.125 to the, how many years did I say? It was 13? 11 years. 11 years. All right. And when I do that, I get this number, but what do I round it to? This is rounded to the nearest cent. So that means to the 100th spot, right? In money, right? So I'm looking here, right? Nearest cent. I look after it's a 2, and it keeps it the same. So I can just copy and paste this. It's $4,603.82. Submit. Yes. Bam. All right, let's look at one more depreciation problem. Oh, interest. Every time there's interest, it's you round it. It goes up. It's growth. So anything with interest rate is a growth one. So, but we're not going to do that one. We'll do one more. Again, interest goes up. We just did something like that one. All right, here we go. An element with a mass of 330 grams decays at 25.5 per minute. All right, so again, I got to starts at 330 and move this decimal spot over twice. So it's 0.255, okay? Yeah, you can put the 0 out in front, so it's going down. All right, so 330 grams. This is a science problem. So it's decaying minus 0.255. For how many years? 5 minutes. So time, it doesn't be years. It can be time interval, 5 minutes. Bam. You get this one, and it says rounded to the nearest 10th. So this is the 10th spot right here. After it is a 3, so 75.7. Keeps it, doesn't round up, keeps it there. So it's 75.7 grams. All right. So the big things is making sure you convert your percent to a decimal. Then you plug it into this formula. If it's growth, it's plus with the 1. If it's decay, it's 1 minus into these problems. And using your Desmos calculator, making sure you're rounding to the nearest correct spot. Okay, so that's it for today's video. Work through these problems. If you have questions, let me know. Thank you for watching.